Azure story. Sorry. Yep. No, that's good. Essentially, kind of the continuation of the Azure journey, and we also talk about certain key innovations around decoupling of storage and compute. Then we delve into specifically Azure Synapse components. We've got different processing pools, the compute aspect of Azure Synapse, and then we also have kind of the different storage options that Azure Synapse provides. And then we go into kind of the pipeline, the capability of pipelines, the ELT services that Azure Synapse has. And another thing that I'm really excited about is some new features that are, we have Cal Yella from Microsoft here that we're gonna kind of talk about some new features that are up and coming in Azure Synapse that are something I'm really excited about and looking forward to. Then we'll kind of close off with kind of a very basic demo. We'll kind of give an overview of the Azure Synapse environment, the pools, the storage capabilities and pipelines. This is just going to be like a quick overview, but certainly in the comment section, I would encourage everyone to kind of, alongside your questions, also give, as we go through the presentation, give more suggestions and ideas of specific Azure use cases, Synapse components that you guys are interested in, and would love to do kind of follow-up presentations on Azure, those features of Azure Synapse that we see in the kind of the comments and the questions that we get. So with that, let's get started let's start talking about the traditional data warehouse. Kind of the pre-SQL DW days, we had most of the data warehousing was structured data. We had canned reports. We had to move data and kind of format data, you had to know kind of what you were looking at, and you had to know what type of analysis you needed to do within the data to get any value out of it. There was little, if any, kind of AI, ML kind of workloads in the traditional data warehouse. And essentially, we kind of moved away from that with the advent of kind of the big data workloads that started coming in. And obviously for most of us that are familiar, we don't necessarily just mean big data as in volume. We also mean variety. You've got unstructured, structured images, audios, and also the velocity of data. You've got data coming in, not just in kind of batch format, kind of T-1, you had data coming in real time and IoT. And then in addition to the volume of data, what we typically call big data, right? And then with big data capabilities and compute capabilities that came about, we also had algorithms that were typically too resource intensive, were not possible to do cheaply with the big data platforms and the compute and storage capabilities that they provided. So that gave rise to a lot of data science scenarios and the use, in addition to the users of kind of the operational reporting, ad hoc reporting, we had users within the data science space that we were catering to. And data science users' needs often varied from the users that were kind of typically your traditional users. The workloads that they have were kind of very resource intensive, but for a short period of time. And they often needed access to large amounts of raw data, which ended up also being primarily historical data, not necessarily kind of real-time analytics that or kind of the analytics that kind of the operational reporting users were typically using. So in addition to that, some key innovations that kind of have been more recently within data warehousing have been the decoupling of storage and compute. Basically, the capability kind of separate storage and compute is very critical, because now you have the ability to store large amounts of data within cloud platforms that necessarily you didn't have to know what you wanted to do with. So if you have large amounts of data that you're getting, but you're not yet sure what to do with it, in the old method, when you had to buy hardware and storage together, you're kind of investing a lot of resources into that storage without really knowing yet how you're going to end up using it. So this decoupling of storage and compute has really opened a lot of kind of gateways into the analytics that we're now able to do in a much more kind of cost-effective fashion. So that brings us to kind of those couple of slides were kind of the foundation into the need of kind of solutions like Azure Synapse. And essentially, just to kind of clarify, you had Azure Synapse is basically a continuation of products such as SQL Data Warehouse that were predecessor to Azure Synapse, and several of the use cases we mentioned above, kind of marrying your kind of relational traditional data warehouse with big data platform and use cases that are specific to big data. A lot of those were merged with the SQL Data Warehouse platform, and Azure Synapse is a continuation of that. Certain new use cases were added into Azure Synapse that we'll talk throughout the presentation that provide you more capabilities and more functionality to be able to handle data that's in your traditional kind of relational data sources, data that's in your resources in big data resources and AI and ML capabilities, all kind of under one roof, which is essentially the modern data warehouse as we most of us are using nowadays. So within Azure, what are kind of the components and features that you generally have to look at? Many of you, if you have kind of looked at Azure, you know it's broken out to 4 separate areas. You've got things such as the capability to ingest data. You've got capability to store data. So within ingestion, you've got ADF pipelines, ADF mapping data flows that can take data from your various data sources, link services that can connect to various data sources, kind of you do your extract and loading into Azure Synapse. And when you load it, you've got various storage capabilities, such as relational databases. You have Azure Data Lake Gen 2, which is essentially blob storage, where that you can basically your data lake capabilities. You've got Spark tables, and also a different type of database that's Cosmos DB, which we'll talk about a little bit more. The third option, the third piece of it is the compute. So you've got your storage and you've got your compute, and the compute capabilities, when we're talking about Azure Synapse and the storage capabilities of Azure Synapse, within each of the storage capabilities, you've got different compute capabilities, and depending on the type of storage capability you want to interact with, Azure Synapse gives you different compute capabilities. So, and you've got, for example, with relational databases, you've got something called Sql Provision Pools. And also in certain use cases, if it's Sql Provision Pools can work with relational databases. Also, they can work with Azure Data Lake Gen 2. And this particular piece, the Sql Provision Pools, these were also part of your SQL Data Warehouse platform. Some of the new features that are part of Azure Synapse components, which I'm really excited to talk about, are something called SQL On Demand or Serverless Pools. This is a very unique capability, a new capability that's part of Azure Synapse that wasn't really part of SQL Data Warehouse that we'll talk about, and also the ability to have Spark pools. And then the last piece is the data visualization. When you talk about Azure Synapse, you are talking about all these capabilities in one umbrella. So typically when we're dealing with data warehouses, you've got different use cases. What Azure Synapse does, and mind you, you can do all these things in, with various services in Azure. What Azure Synapse does, it gives you kind of one glass pane, one kind of window into one client tool and a window into all these capabilities under one umbrella. And when we work with Azure Synapse, kind of what we work with is inside a workspace. And kind of the window and the umbrella that you get into Azure Synapse is this Azure Synapse Studio that also gives you kind of monitoring, management, and security capabilities. So let's start talking a little bit more about the storage capabilities. You've got your relational databases, you got Azure Data Lake Storage Gen 2, you've got Spark Tables and Cosmos Lake. And we'll talk about these in a little bit more detail, and I apologize in advance for the wall of text here, because there's a lot of information and what you can do with each of these. But as I mentioned earlier, with relational databases, these come with standard relational databases, come with kind of your dedicated Sql pools. So when you create a dedicated Sql pool, you get a relational database alongside with it. And for now, you can only really query it using dedicated Sql pools. And in use cases where you need kind of cleaned and curated data, and your traditional applications such as dashboards, ad hoc, and operational reports, when essentially we kind of need to know that we want to know the schema, we know what we want to query, and just like we do in our traditional data warehouse applications right now, you would use the relational database capability, the relational storage option here. Then you've got your Azure Data Lake Gen 2. And this is where you get into really the capability to store, unlimited amounts of data for long-term storage in a much more inexpensive fashion. You've got, the option to kind of keep data, just in case. You can integrate, structured data, unstructured data, your text, audio, your video, and a lot of use cases when the schema is not defined until you kind of need to query it. So I mentioned you've got some use cases here where in relational databases where you've got, you want to use kind of data that's kind of cleaned and curated and exposed in reports. With certain data, you can also do that with Azure Data Lake Gen 2. You've got, data that's kind of structured data that you have in Azure Data Lake Gen 2. You can expose that directly into a data visualization tool, such as Power BI, all inside Synapse. That leads to kind of much more speeding up your ETL processing, and it's ideal for your kind of extreme AI and ML models, and also landing your streaming data. So you also have your kind of Spark tables. You can create Spark tables, which essentially also, like all these storage options, they underneath the table, underneath the layers, they all utilize kind of Azure kind of data lake storage, right? So at Spark tables also utilize Azure data lake storage, and basically it's kind of, you can have a Delta Lake kind of a layer on top of Azure Data Lake storage. And last but not least is your Cosmos DB. It's basically a NoSQL database, and it's really designed for more of your OLTP type of applications, such as gaming, retail. It allows performance to be scaled up or down in a very elastic manner, and supports kind of millisecond reads and writes to help avoid any lags. And some of the kind of the famous applications that use Cosmos DB, Halo and Walking Dead actually use Cosmos DB for gaming applications that have kind of many requests, kind of trillions of requests per day, and it's able to scale to that level of kind of availability and scalability. So this storage option is new in Synapse as well. So now we get into more about processing pools, and this is where it gets really interesting. As we mentioned, we've got three types of processing pools. You've got your Sql Provision Pools, which kind of access your kind of traditional data and your kind of your relational databases. You've got Serverless Pools, which are new, and Apache Spark Pools. And the next few slides, I'm going to describe a little bit of differences between these pools and kind of which use cases you would use one over the other. So with Sql Provision Pools, so this is just a kind of snippet from the previous slides where you've got Sql Provision Pools. You can access data in your relational DB and your ADLS Gen 2 data lake. When you create Sql Provision Pools, you get one database per Sql Provision Pool, as we mentioned. And the key differentiator here between the Sql Provision Pools and the Serverless Pools and the Apache Spark Pools, you get dedicated resources to run your jobs, okay? So what does that mean to get dedicated resources? We'll talk about that a little bit later, keep that in mind when you think about kind of your Sql Provision Pools. You have to have, you get dedicated resources to run your jobs. In addition, you've got massive parallel processing, the ability to kind of distribute your workloads on kind of multiple nodes. And when we talk about dedicating resources, what we're really talking about is this fourth bullet point here, which is you reserve something called DWs. It's a proprietary unit within, specific to Azure Synapse SQL Server Provision Pools that combine CPU, memory, and I/O. When you start up a SQL Provision Pool, what you're really reserving are these units for the amount of time that you will be working on the SQL Provision Pool. Those resources are going to be dedicated for you. So when we talk about dedicated pools dedicated resources, you can think about it as like a pool. If you have a pool, you got multiple lanes. When you spin up a dedicated pool, you reserve certain lanes. So in this example, I reserve these lanes, and you can have lanes up to 60 kind of lanes or nodes you can talk about that you reserve at a time. And while you have them up, nobody's able to enter them. That doesn't mean the whole pool belongs to you, and doesn't mean those resources belong to you forever. But as long as you have the dedicated pool up and running, those resources are dedicated and reserved for you. Now you can turn them off when you're done using those resources, then they'll be free for others to use. But while you have it on, it's important to remember that those resources are reserved for you. So if you have an Azure subscription and you created a SQL Provision Pool and you kind of spin one up and you have a bunch of credits and you forget to pause it, turn it off, it'll keep, since Azure has reserved those units for you, it'll keep draining those resources. So that's one thing to remember as you're kind of working with dedicated SQL pools. So this concept of so how do these pools process data, right? This concept of kind of control node versus compute nodes is very similar across the different pools. You've got a control node and a compute node. The control node in dedicated pools, basically when you run a query, the control nodes gets a specific job. It decides how to distribute that job across the different nodes and basically distributes the workloads across the different compute nodes. And then those compute nodes kind of process the data and bring it back to the compute node and kind of display the results. And as I mentioned, this is similar in dedicated pools and serverless and Spark pools. So let's use an example of MPP. For MPP and dedicated pools, you've got need to make 10 sandwiches. 100 sandwiches you need to make. And you've got 10 workers to do it. So 100 sandwiches is like your query. Your 10 workers to do it, 10 workers are your nodes. So the control node, gets a request, hey, I need to make 100 sandwiches. It's going to decide the best path to distribute that workload across the nodes. And it'll say, oh, I've got 10 nodes, 100 sandwiches. Okay, let's split it out across the 10 sandwiches. The 10 worker nodes with 10 sandwiches each, and to process the data. Now, the last bullet point you'll see here, when you create tables within dedicated pools, you have Azure Synapse gives you a little extra capability and control over the way that data is going to be distributed, which data is going to be pruned and accessed, and then which data is then going to be split across those nodes. If you create these distributed keys, that's like an important concept to remember. If you, in addition to the logical partitioning that happens within Synapse, you have the ability to define additional distribution keys on top of your data that gives you some more control in kind of pruning the data and kind of more fine tuning as far as the compute that you're going to use to limit the data that's going to be queried and passed to these worker nodes. So this capability is specific in dedicated pools that, depending on your workloads, you can, define your distributed key that splits the queries across the nodes that you have. So with that, we go on to serverless pools. So with serverless pools, the key difference that we mentioned with serverless pools, you don't have the ability that the last slide that we showed, you don't have the ability to have kind of, you have the logical partitions that you get with, on your Parquet files that Sql on-demand pools or serverless pools give you the ability to process on, but you don't have those distributed keys that we mentioned for dedicated pools. But the key advantage and the key use case to look at serverless pools is that in dedicated pools or the Sql Provision Pools, we had reserved lanes. In serverless pools, when you are running queries, essentially you can run T-SQL queries on your data in your, on your data lake, in your Spark tables or Cosmos DB, but you're not reserving any compute up front. So when you have a query, only when you run that query that you're going to be charged for the resources. You're not going to be charged for the resources while the SQL and the serverless pool is not running. So by default, you get one serverless pool with every workspace that you create. But only when you're ready to query your data with a serverless pool are you going to be charged for it. So some use cases where it's really ideal for is basic discovery of data. You want to kind of explore the data that's in your storage. You don't want to do any kind of like extra ETL to put it into like a relational table. You just want to look at the data in its source. You're not able to do that with your SQL on-demand pools. You can put T-SQL views on top of your data lake, something called a logical data warehouse. So the users get a feeling of just like they're querying a traditional relational database using T-SQL on top of your data lake. So this is kind of a very interesting capability. And as you'll see in the demo, this is like hardly any setup is required when you spin up a workspace. From the time you spin up a workspace and you kind of load some data into your data lake, like a Parquet file or even a CSV file, the time it takes from that to be able to query it with a SQL, like a serverless pool, the Synapse has really kind of shrunk that time and that processing time to do analysis on that data. And other use cases that can be used for is a quick way to transform the data in your data lake. So just the data that's sitting in your data lake, you've got Parquet files, your other kind of text data. You can query that data and feed it to your BI tools, kind of without any ETL or kind of staging it in any other kind of additional layers. And another interesting capabilities. So you've got the ability to use Spark pools to create Spark tables. And so you've got that capability to work with kind of the Spark compute power. And when you create the tables, so generally Spark pools are a little bit more expensive than serverless pools, but when you create output of Spark pools, create Spark tables, you can turn them off and you can use data, basically your serverless pools to query data in your Spark pools. So what are the cost components? So since you don't have any dedicated resources, you're not reserving any data warehouse units like you are with SQL dedicated pools, your essential costs are the $5 per terabyte. And so obviously if you have a kind of query that's a massive kind of that requires massive computational powers, what Synapse gives you is the ability to put cost controls. Obviously, you can do it, as you can see in the screenshot, in a daily, monthly, or weekly level. You can set the limit that, the compute that is incurred by the serverless pool has certain limits. But you don't need to spin anything up. Essentially, when you've got the serverless pool, when you run the query, that's where you incur this cost in the relative to the amount you use in compute. So the last but not least is the Apache Spark Pool. So you've got the capability of Spark, you've got that now within Azure Synapse to use. So the way the Apache Spark pools work within Azure Synapse, when you create a Spark pools, you're not paying for the pool. However, when you start paying for Apache Spark pool in Synapse is when you kind of run a query. So when you run a query, it creates a connection to a Spark pool and it's given a context inside the main driver program of a Spark application. The Spark context is then responsible to kind of connect to the cluster manager, which is Yarn. And it's very similar to as I mentioned earlier, you got the control node concept and worker node concept. And then Yarn has the method to allocate or contract out to the worker nodes the different workloads that it deems appropriate. And then the worker nodes then return data back to the Spark context to lay it up in your query results. So once again, the pools are not what you pay for. You pay for the compute that's used. When you set up an Apache Spark pool, you have the ability to do it with kind of three real options. You've got the node size, which is essentially kind of vCore and memory capabilities. You've got the option to set up number of nodes that you'll use. And you also have the option to kind of set up whether it'll auto scale or not. Now, you notice here, there's an option to, enable auto scale or disable auto scale. If you disable it, then this scale goes away. And we'll kind of show that when we talk a little bit about the Spark pools in the demo. And if you set up auto scale and you have it enabled, you can set a minimum and a maximum, and it'll, depending on the query workload, it'll decide how many nodes to utilize for that specific queries. And the combination of these capabilities kind of gives you the estimate of per hour that is going to be incurred by this Apache Spark pool. So so when we got our, we covered our kind of storage capabilities. We've got our, relational data warehouse, relational database capabilities. You've got our, the capabilities of the data lake, Spark tables, Cosmos DB. The capability of kind of the ETL and ELT within Synapse is also there. And generally, you split that capability into kind of three broad areas. You've got your data movement, where essentially you're doing your extract and load. You've got your data transformation, where you're kind of transforming your data, and data control, and your orchestration of your ELT jobs. So this topic of pipelines can be a whole nother session in and of itself. It's really a kind of a massive topic, because for example, for your data movement, with your extract and load, you've got so many connectors available, so many resources that you can connect to, and you can bring that data into your Azure Synapse environment as kind of external storage that's connected to your Azure Synapse environment. With transformation, because you have your dedicated pools, you've got your serverless pools, and you've got data in your Spark pools, you have so many options to transform data that, once again, it's a whole session in and of itself. And with data control and ability to kind of orchestrate ELT jobs, a lot of that is kind of continuation of what you can do in Data Factory as well. But the processing pools and the capabilities of the different transformations that are there, with the addition of your Spark pools, it's really a wide variety of capability you get with pipelines. So certain definitions that I'll cover here for the pipelines is your link services. So when you are doing your data movement from your kind of your source to target, certain keywords that'll kind of come up, you need to kind of keep in mind is your link services. Link services are essentially your connection strings in SSIS. That's what gives you the ability to connect to the different data sources that the Azure Synapse allows you to connect with. And another kind of key word that kind of comes up in usage of pipelines is integration runtime. So as you're moving data from source to target, or you're doing transformation, and your integration runtime is the compute environment where the activity is executed. So you think about it like the kitchen, where all the ingredients are combined and cooked before serving. So if you've got your ingredients in your different data sources, the integration runtime is something we define when we're running pipelines to kind of give you a compute environment where the data movement, transform, and control flow activities are performed. So with that, I'll kind of switch it over to Cal Gilla from Microsoft, and this slide will cover some of the new features that are coming with Azure Synapse.
Thank you. Audio check. Can you guys hear me?
Yep, you're good.
All right.
You're good.
Hello, everyone. My name is Cal Yella. I'm a principal program manager with Microsoft for Azure Synapse from the Azure Synapse product group. I want to just quickly touch base on some of the new features that are either readily available now or in a preview stage with Synapse Analytics. So one thing you may have understood from the discussion that Ali did. So Azure Synapse Analytics is not a single product or a service. It's an ecosystem that combines different services required for different parts of different use cases, analytical use cases, as a single entity, a single service together into one Azure Workspace that you can use to as a single pane of glass to control different either dedicated pool or serverless or Spark. You can use any services, any computing engines, any storage engines to meet your analytical use cases. So that's the goal, and we are expanding that further into different, in even more use cases that can work together with Azure Synapse. And that's where these new features I'm going to talk about come into play. For example, if you take the first one, Azure Synapse Link. So Azure Synapse Link is a feature that is available with Synapse Analytics, that's supported by Synapse Analytics, to integrate and run analytics using the data from different other non-Synapse data services. So in this example, I'm talking about Cosmos DB. I mean, right now we have Azure Synapse Link available for Cosmos DB, and also we have Synapse Link available for Dataverse, which is Power Apps and Dynamics 365 and all. And then we're going to increase that support to other types of services, data services, analytical services, like even our own Sql and other services. So if we talk about Cosmos DB, so in a Cosmos DB, you have a transactional store and analytical store where you have data coming in from operational data coming into transactional store at a high speed. You can use that, the analytical store part of that, to directly integrate with Synapse Link. So you can actually run analytics directly from your Synapse engine while working with the data that is in Cosmos DB. So that way, so for example, you can create a Power BI report that runs a serverless pool, that what Ali mentioned before. So you can use a serverless pool to actually, via Synapse Link, connect to your Cosmos DB and process the data and pull the data, pull the reports, analytical reports through to your Power BI, all the way from Cosmos DB through Synapse Link and through SQL Engine into your Power BI. So that's the power of the Synapse Link to support that kind of, you don't have to pull the data, preserve the data, make copies of your data into Synapse or any other platform. You keep the data in place where you want, and then pull and process and work with the data using Synapse Link provided by Azure Synapse Analytics, right? The next one is Purview Integration. So for those of you, I don't know how many of you are familiar with Purview, but it's our data governance solution. So if you look at the second screenshot showing here, so this is how a sample Purview looks like. My apologies if the picture is not very clear, but basically, so from Azure Synapse, so Purview is a data governance solution. So you can actually create a map of all your data products, wherever the data is. You can create a map of all your data products in one place, and you can handle that data. You can identify where the data is. You can categorize and send sensitivity of the data and handle the data appropriately. So all that you can do it from one place using Purview for the data governance. And now we increase the support of the data governance solution called Purview into Azure Synapse, which means you can use Azure Synapse Studio now to connect to your Purview service, and then all the data mapping you did, you can visualize through Azure Synapse Studio, as you see in this example here, right? So that gives you that flexibility, and that follows that single pane of glass architecture we're talking about, where you can do everything. You can control, you can run, do many of your analytical use cases using Azure Synapse Studio without looking into different tools. Next one is Synapse Data Explorer. So Azure Data Explorer is a product that is available for a long time from Microsoft, that actually we use internally also for handling massive amounts of data while still being able to process that data in real time using human-friendly query language. So we use a language called Kusto KQL, Kusto SQL, which is somewhat similar to SQL, but it's more human-friendly, quote unquote. So we can use this data explorer to explore the data, pull the data, ingest data from different sources, be it IoT hubs, what be operational data, IoT kind of data. All that data you can ingest into Data Explorer, and then you can use Kusto queries to run analytics and run queries from the data, the massive amounts of data with high performance and concurrency. So now with the Azure Synapse, we have that integration. So we now have integration into, as you see on the screen, the last screenshot there. You can integrate Azure Data Explorer with Azure Synapse, and you would be able to work with as a single entity to control and to use to handle the data that's coming into Azure Data Explorer through Azure Synapse, and you run your analytics on top of that data. All right. So these are the three important services that are available to further improve and make your Synapse analytical solution more powerful than what it is, right? And on top of that, we also started adding more and more features and functionality into Azure Synapse Analytics ecosystem. So some of the examples are Spark engine. So Ali mentioned about the Spark pools we have. So we now have Spark 3. Actually, as of last week, we even have 3.1 support. So Spark 3.x support, which is the most recent Apache Spark version, which has more performance and other benefits into the Spark runtime. So we now support that with our Azure Synapse Spark engine. So you can use the additional features like graphical GPU support, partition tuning, and other things that are available with the new version of Azure Spark runtime. And also the Delta Lake support. So Ali already mentioned briefly on that. So we now, the Delta Lake is fully supported by our serverless platform. So far, if you have Delta Lake in your analytical system, you may have to use some other services like Databricks or something, or but now you can use our Spark engine and serverless engine, which are supported with the Delta Lake. We're eventually also going to support with dedicated pool as well. So the Delta Lake support is going to be improved moving forward. All right. So these are the new features I want to talk about. And real quick, I just want to, there are a couple of links I provided there. One of them, the Synapse Success by Design. This is a website that we have a process for implementing your Synapse solutions. So we built this process and best practices on how to smoothly and successfully build your Synapse-based solutions. We provided all that details in that Synapse Success by Design. I strongly recommend you to look into that and use the guidance provided in that for any of your Synapse-based solution implementations. And then last but not least, Microsoft Ignite is coming up very soon, November 2nd to 4th. I strongly recommend you to attend that. It's a virtual conference. You can register using the link provided in that in the slide. You can attend that, and we are announcing some very new and cool features, not only with Synapse, but other parts of Azure platform as well. So I would strongly recommend you to attend that. With that, if you have any questions, please let me know.
So I would I'll go into the demo actually. And what I would kind of suggest, if anybody has questions, two things, as I mentioned earlier. If you could post some questions in the chat. And if you haven't done, for those who haven't done already, after listening to the new features or contents of the deck that was provided, and also ideas of things in specific that you would like to see in a demo, or things that you would like to cover in more detail for future talks. So with that, any questions so far?
I have a question.
Yes.
On the snaps, when you use the query different data systems, well, how does the snaps create the metadata catalog for all the different the different data, different system data lake, SQL Server?
So let me just repeat the
Yeah,
question
sure.
for the audience. So the question was, within Synapse, when you're querying the different data sources, how does Synapse create metadata for the different layers, your different data sources that you're querying? So
So that's a very good question. So yeah, obviously, so when you have these different engines and you're handling the data through different engines and creating different tables and logical data warehouses versus physical data warehouse, the question comes in when you're interacting that together, how the metadata is going to be managed. So we have metadata sharing. So you can actually share the metadata across the engines. So you can use that, for example, a table that you created using serverless, you can use that with a dedicated pool. So you can, the visibility, the metadata visibility is going to be, I mean, right now it is at a limited fashion, but that's going to be increased. So we are going to provide a common metadata platform that the metadata can be shared between, so you can transparently use the engines no matter what what you use to create the tables, objects, regardless.
any other questions? Let me look through.
We're looking through some questions in the chat.
Yeah.
Okay.
Sounds good. So with that, I'll jump over into the demo. Give me just a second. Okay, so are you guys able to see my screen?
I can.
You can, the screen up here. Okay, great. So I'm going to talk in the time that we have left around the use cases around kind of how to actually create a Synapse workspace. We're going to talk a little bit about the various pools, how to create them within the Azure portal, and run some queries, like I was saying, with data that's in a data lake storage, data that's ingested into a data lake storage, show you the capability to be able to query that and how easy that is within Azure Synapse. So within Azure Synapse, to create a workspace, in your Azure portal, you go and you create a Azure. So I've got kind of two workspaces here, but if you were to create a new one, essentially the things you have to define is a resource group. So when you create an Azure Synapse workspace, you have to specify the name of the workspace, you pick a region, and you have to create a data lake storage Gen2 account and your file system name. These are the basic things you have to create when you create the Synapse workspace. I won't go through these steps here, but essentially when you have created the Synapse workspace, you can launch the Synapse workspace. And this is kind of your main area where you're able to, when we talk about that one pane of glass, to be able to look at the various type of workloads, work with the various pools, work with the various storage options, and be able to kind of visualize data, as well as create pipelines to kind of ingest and transform data. This is that one pane, right? So we create the analytics workspace, then we can, once we create that, we create the resource group, the data lake storage account, and we're able to then launch the Synapse Analytics workspace. So in here, you see on the left side, you've got various options. You got your home. Over here, you've got the different data, the different data options you have. If you notice, you've got the workspace and you've got the link. So the Azure Data Lake Storage Gen2 account is here. We can also create multiple link sources that may not be part of Synapse, but different kind of data storage locations that are that can be linked with Synapse. So they're kind of external. The storage is external, but they can be linked and they can be accessed from within Synapse. You've got your kind of develop tab over here. You can kind of create your SQL scripts, your notebooks, data flow. You've got your integration where you can create your pipeline, and then you've got the capabilities to monitor the different jobs running on your Spark pools. I like to come here and show you specifically the pools. So as you see, there's the Sql pool. The built-in comes by default, as we mentioned. So when we create the Synapse, this comes in by default, and it's online pretty much all the time. So even though it's online, since I'm not running any jobs against it, this will not be incurring any charges, right? So within this workspace, I'm paying for storage, right? I've got data here that I'm storing, right? I've got some dedicated tables, and I've got data in my kind of Azure Data Lake Gen 2 and blob storage. I'm paying for that, but I'm not paying for the serverless pool until I run a query against it. And also I've got my dedicated SQL pool. This pool, as you can see, I've paused it, so I'm not incurring any charges for those DW units. I'm not incurring any charges for it, but until I actually run it. If I click the play button and run it, then I'll start incurring the charges for it. And I've got my
scaling option, so you can actually, so you're running a DW100, but you can also scale.
Yeah. So let me just go real quick to the Spark pool. So you've got same here. I've got my Spark pool. I've created here, but this is not going to incur any charges until I actually go ahead and run it. So I'll go back to the pools here, and let's kind of create a new one. So obviously you cannot I can't create a new built-in one because you only get one per workplace. When I click new, it gives me the ability to, so when you click new, it's only the dedicated pools that we're creating, and you can spin up multiple pools, and you get, as I mentioned, one database, one kind of relational database per pool you get with this. So when you create a dedicated pool, you've got different performance level that you're able to select. So obviously with the region, I'm kind of limited to what I can do, but I selected the lowest option. So if you kind of hover over this, you'll kind of the dedicated, the DW units here is what it defines here, which is that unit that we were talking about, that is going to be your that it's a combination of your compute, your memory, and IO. And the more resources you dedicate, the more your per hour cost goes. So
basically, if you recall, when you talked about the Sql pool, right? The swimming pool, you get multiple pools. So with 100 to 500, you get one lane of the pool. At the higher end, at 30,000, you get 60 pools to swim through. Right. So that's the difference. So the higher, so as you increase the DW, your memory your computing power increases by CPU and memory and IO. So that's the distinction.
yeah. So so basically in here, that's essentially the concept of the dedicated pools here. If we go into additional setting here, actually, let's create it. So when we first create the pool, as I mentioned, when you create it, it's going to be running. And before, if you guys saw in my data, I only had one database. So after this is done deploying in my workspace, you notice I've only got this one database over here. Let's wait for it to deploy here. So we'll kind of come back to this. It's done deploying. Let's wait for it to deploy. We'll kind of come back to this, and we'll show that, you know, once you create it, you'll get a new database with it. So the second thing here, we were talking about the Spark pools. So as you showed in the slides, you've got the option here of the node size family, you know, and the node size. So so in here, you've got different cores you can select and different options. This obviously controls the number of kind of the processing that your node is going to have. And you also have the ability to set up, as we mentioned in the slide deck, to set up the auto scale. And over here, I can set up, you know, you can start off with the most minimum. You know, if your query only requires 3 nodes, it'll only use 3 nodes. If it needs to scale up, you can have it set up to, you know, more nodes. So as it needs to, it'll keep spinning up more nodes to process your job. If you disable that, you only have the option of, you know, these dedicated nodes, and it's set. There's no auto scaling that happens. So kind of one thing we'll mention here. See if it's still running here. It's still deploying. So one thing we'll mention here. So I've got data here that if you guys have a subscription, you know, if you don't, I would encourage you to get one. And essentially, you are able to ingest data. There's a lot of data sets available. So in the within Azure Synapse, you've got different data galleries that you can go into and load certain data. So I loaded certain data with some Parquet data. There's a NYC trip small Parquet data file that's here. And I've also got data here in some CSV files. So, and remember, this is Parquet data. So typically when you had to load data into, when you had to process Parquet data, within kind of traditional environments. You had to maybe run up, kind of spin up a Databricks, create a notebook, write some Spark SQL, and then you would run that compute and create some results and do some analysis on that data. With this Parquet file within Synapse, it's as easy as kind of clicking here, and you've got the top 100 option here. So I can write T-SQL against that Parquet data. And the way it's possible, it uses this open row set kind of function. And in here, it specifies the file that the location of the file, of that Parquet file, that kind of houses that data. So this was the account that I created. When I set up the workspace, you remember you have to set up like an Azure Data Lake Gen 2 kind of directory. This is my directory, and this is here's my file, and I'm able to execute this using T-SQL. So this is kind of, it'll take a couple seconds while the built-in pool kind of warms up. It took about 5 seconds. So if I run it again, it'll run probably quicker because it's already in, loaded inside kind of the cache. And this is, like I said, this is Parquet data within Synapse, kind of being able to analyze Parquet data. You can put a where clause on it. You can analyze that data within T-SQL. I could take this data, I could kind of manipulate it, and I can send it over into my, feed it into my Power BI data set directly within Synapse. I don't need to spin up kind of any Databricks or any Spark pools or anything at this point. I've also got data, CSV files. This data is in my Azure Data Lake Gen 2, and I'm able to query this data. Once again, kind of just right click, and that same open row set function is used. I specify the location of that CSV file, and I'm able to run this data using T-SQL within the Synapse pool, using the serverless pool. So basically, this is something, it's very interesting when we talk about the modern data warehouse and the ability to kind of link your kind of traditional relational database loads along with data. Kind of even the Parquet is really still, I think, structured data, but it's still not non-relational data that's in your data lake. To kind of marry those two, Synapse gives you kind of very strong capabilities and quick capabilities to do that. So if we kind of go in here, I've got some, so you guys notice this demo SQL now comes up. Remember when I created that dedicated pool, now it gave me that demo SQL database that I get associated with that pool. I've already got kind of a dedicated SQL pool created here, and in here I've got some tables. I have it turned off. Let me turn on this pool. Yeah, I can just turn it on here. Essentially, I can. So it's still resuming, but I can also kind of show you guys within this demo SQL pool. I can just write a new T-SQL script, and essentially this is your kind of your traditional SQL database. You get your traditional SQL database here that we're used to kind of on-prem. Those capabilities you can get, in the cloud. And, I can do the same operations on such as DML operations. And I'm not sure, we didn't kind of cover that in more detail. For example, you can't really do DML operations within, on top of Data Lake a lot of use cases that require that in traditional databases that you can do with your dedicated pools. And you've also got, let me see if this is spinning up still. I think it's still spinning up. So you also have, I've got data here in my scripts here. I've got a script here, and I'll post a link in the in my I'll post a link to the meetup group of a tutorial that we have that you guys can follow. Let me go in here, quick start guide. And this is kind of a tutorial that Microsoft provides that you can create a Synapse workspace, some of the capabilities around kind of connecting to that data in that gallery. You can set up a built-in serverless SQL pool, analyze using serverless SQL pool, analyze data using a serverless Spark pool, use a dedicated pool, analyze data in storage account, and also visualize with Power BI. So we don't really have time to kind of cover all these, but I would highly encourage going into this tutorial, which, like I said, I'll kind of follow that up into the slide deck and also in the meetup group, and kind of follow along in here and kind of see some of the capabilities in more detail. Kind of in conclusion here, I'll essentially just show this capability within. So this particular query takes data from my that NYC trip Parquet file. I can take this data and I can copy it into, I can create a table within my dedicated pool from data in my Parquet files. And this particular script shows you the ability to do that. So I think I would suggest kind of for given the time constraints with the demo, go into this tutorial and kind of you can see more details on kind of creating Workspace and being able to follow along. With that, I know we're kind of over time. I'd like to kind of stop, see if there's any more questions, and kind of take a pause for a minute here. I think I don't see any more questions here. For those interested in the slide deck, we'll probably follow it up. I think we can do that in the meetup group, right?
We can share a link in the meetup group, so that way it's available to anybody who'd like to see the slide deck,
Yeah.
as well as any additional resources as well. So,
Yeah. So the link back to the tutorial and to the slide deck I'll give there. And I think if there's not any more questions, I think that's it. Thank you very much, guys.
Thank you.
Thank you.